Now let's discuss conservation of isospin. And this law of conservation of isospin is valid. It is valid only in reaction or decays which occur through strong interaction. So if we have a decay through strong interaction, or if we have a reaction involving strong interaction, then certainly this conservation of isospin is valid in those situations. However, the law of conservation of third component, I mean, the third component of isospin, third component of isospin, which is probably symbolized as I3. It is valid in reactions or decays which are due to strong and electromagnetic interactions. Electromagnetic interactions. So what is important here is that this conservation of isospin is valid only in the domain of strong interactions. However, the conservation of I3, the third component of this isospin, it is valid for strong as well as electromagnetic interactions. So I would say here that sigma I is constant. And it is constant for what? It is constant for strong interactions. And similarly, I will say this sigma I3 is a constant, and it is constant for strong and electromagnetic interactions. Electromagnetic interactions. Now, this isospin that we have, it is added exactly same way as the angular momentum is added. The way we have the addition of angular momenta J, the addition of I and I1 is valid. It goes with the same rules of addition as we have gone through that total angular momentum J. So I can say that this I, if I have to have two components, I1 and I2, then this I is I1 plus I2. It's the vector sum of I1 and I2. So I can say that this I has discrete values as J has discrete values. So these values will range from I1 minus I2 to I1 plus I2. And differing in every case by the number equal to 1. So what it means is that if I have the isospin, say I1 is 1 by 2, and it is to be added to the isospin I2 equal to 1, then the total spin that I can have here is, total isospin I will have here is, for I will be, it will be 1 by 2 and 3 by 2. All right. So adding the 2 and subtracting the 2. However, I3, in case of I3, I3s are added just like adding simple numbers. I3 is added just like simple numbers. Simple algebraic addition is subjected to I3. Now let's take an example, and we would like to understand this thing through an example. Now, if I choose a reaction, say for example, I take a pi negative meson and a proton, and this gives lambda neutral and k neutral. Now, if we see the isospin, let's go with isospin of left-hand side here. So here, what I'll have is I will be, it will be 1 minus 1 by 2 and 1 plus 1 by 2. Okay, so what I'll get, I'll get 1 by 2. When I subtract the 2, I'll get 3 by 2 when I add the 2. So this is the left hand iso spin. Now the iso spin of right hand, iso spin of RHS. So that will be I. Okay, what I have is lambda 0. So that will be 0 minus 1 by 2. Okay, and 0 plus 1 by 2. That should be the case. So what am I going to get here is taking the magnitude, I'll get 1 by 2 and 1 by 2. So since we can see that the iso spin of right hand side is 1 by 2 is equal to the iso spin of left hand side 1 by 2. Here I have 1 by 2. Here I have 1 by 2. So the given reaction can occur. This reaction can occur through strong interactions. And also, if I3 of, so if I take I3 of LHS, so if I choose I3 of left hand side, so what am I going to get? So certainly I'll have 1 plus 1 by 2, that's going to give me 3 by 2. And I3 for the right hand side, what will be for RHS? That will be 0 minus 1 by 2 equals minus 1 by 2. So what we see here is that in the given reaction, the given reaction cannot take place via electromagnetic interaction. Because when we added I3 to both left-hand side and right-hand side, the two are different. Their values are different. So we can say here that the given reaction that we have, this reaction cannot take place through electromagnetic interaction. Yes, definitely this reaction is going to take place through strong interaction. Now let's take another example over here. Say for example we have pi meson, a neutral pi meson, gamma and gamma. Now what will be the iso spin of the left hand side? That is simply equal to 1. And iso spin of right hand side, yeah, that's going to be 0 plus 0, that's going to give me 0. So what we see here, so since this iso spin is not conserved in the given decay, we can see that the iso spin is not conserved. Therefore, this reaction cannot take place through strong interaction. This reaction cannot take place through strong interaction. However, if we have I3 of the left hand side, what is I3 of the left hand side? That's simply 0. And what is I3 of the right hand side? I should write LHS. And what is I3 of the right hand side? That is 0. So what we see here, that the third component of the iso spin is conserved in the given decay. So it can take place through electromagnetic interaction. So this reaction cannot take place through strong interaction, but this reaction can take place through electromagnetic interaction. Electromagnetic interactions. Now, let's take another example of say lambda neutral proton and pi negative. So what is the iso spin of left hand side in this case? That simply is 0. And what is the iso spin of right hand side? Okay, so we have proton here, so this is 1 by 2 minus 1, and we have 1 by 2 plus 1. So we'll have 1 by 2 and 3 by 2. So iso spin of the left hand side, we can see, is not equal to the iso spin of the right hand side. They are different. That is, this iso spin is not conserved. So hence the given decay is not possible through strong interaction. It's not possible through strong interaction. Okay, now if I take into account the third component, that's I3. Okay, now I3 of left hand side, that is simply 0. Okay, and I3 of the right hand side, if I take I3 of RHS, so I3 of the RHS, that is simply 1 by 2 minus 1, that is minus 1 by 2. So what can we see here is that I3 is not conserved. It's not conserved. In the right hand side we have minus half, in the left hand side we have 0. So I'll say here that the given decay is not possible through electromagnetic interaction as well. Not possible. Not possible through electromagnetic interaction. Using isospin, not possible through strong interactions. Hence, the given decay can occur only through weak interactions. It can occur only through weak interactions.